Hi, and welcome. We are in the midst of our discussion of a variety of type of what are called KSP reactions, so solubility product. And the question here is, will precipitation occur? When you see that phrase, will precipitation occur, I want your mind to immediately jump to Q. Because will precipitation occur is asking the question, is given these initial amounts, will the reaction proceed towards reactant side? We always put the solids on the reactant side. So if in a KSP where we have our solids in equilibrium with aqueous ions, if this reaction proceeds to the reactant side to achieve equilibrium, then we're going to see a precipitate form. So this is what it's saying. I know, will precipitation occur? This is the gist of what we're after here. So let's take a look. Identify our substances. So the question is talking about the precipitation of nickel carbonate, gives us a KSP for nickel carbonate. I think it would be really helpful to write that equilibrium for nickel carbonate. Okay, so I've identified that as a slightly soluble salt. Now, I have nickel chloride, 0.0024 molar, is equal to my concentration of nickel chloride. And then I've got 1.2 times 10 to the minus fourth molar potassium. That's equal to my concentration of potassium carbonate. Okay, let me erase this. This looks like a not equal to sign. I don't like that there. Equal to. Now, it can help for you to go back to what you learned in your standard chemistry or your standard math classes or physics classes. List your givens. Okay, so these are my amounts here. I want to identify them. Those are both soluble salts. So that means that we're going to have a stoichiometry. Stoichiometries feed into the initial row of a rice table, and lo and behold, that's how we calculate Q. So if we were to do my rice table here, we're not going to have to fill the whole thing out because it's asking us about Q. Will it precipitate is a question of Q. Now, I'm going to do these the fast way. I think that's the fast way. I have nickel ion, that's part of my reaction, and I have 1 mole of nickel for every 1 mole of nickel chloride. So that means my nickel ion is 0.0024 as well. For carbonate, I have 1 mole of carbonate for every 1 mole of potassium carbonate. So my carbonate ion is also 1.2 times 10 to the minus fourth. So now that I have my initial values, I have enough information to calculate Q. And if I know Q, I can compare it to K, and it's in comparing Q to K that will decide whether a precipitation occurs. So Q is set up just like KSP, only it's the nickel ion initial times the carbonate ion initial as opposed to equilibrium. So if I plug those values in, I get Q equal to, if I've done my math right, 2.88 times 10 to the minus 7th. So now we have to decide, do we have too much product or not enough product as the system is achieving equilibrium? And so I'm going to compare Q to K. K is 1.4 times 10 to the minus 7. So K is less than Q. And if you put K on the left, this points to the direction we're going to proceed. So that means this is going to proceed to reactant side. So I'm going to lose product. I'm going to gain reactant, and that's a solid, and that's a precipitate. So the answer is yes, we're going to gain or form a solid precipitate if we added those two solutions together. All right, let's do another one of these. Hopefully you're starting to see where this DSE, this doc saves, dilution stoichiometry equilibrium framework, is helping. So we have two soluble salts. So this is a soluble salt, and calcium nitrate's a soluble salt. So we added a volume to a volume. So we have a beaker of one, and we're going to add it to a beaker of the other to form one solution. So we have to voom voom. So my concentration of Na2SO4 is going to be 50 times 0.00152. And if I add 50 plus 50, my final volume is 100 times my new molarity. And so my sodium sulfate molarity is equal to 7.6 times 10 to the minus 4th molar. And likewise, if I did my calcium nitrate, I have 50 times 0.00125 is equal to 100 times its new molarity. Its new molarity is 6.25 times 10 to the minus 7th. Oh, sorry, 4th molar. Okay, now what we're trying to find out is, will calcium sulfate precipitate? So when I put these calcium ion, a source of calcium ion in the solution, and a source of sulfate ion in solution, the question that's being asked is, will it shift to the reactant side to make that solid precipitate? And when we're asked about a precipitate, it means we need Q. All right. Now, if you look at my formula, I have a 1-to-1 mole ratio between my sulfate ion and my sodium sulfate, and I have a 1-to-1 mole ratio between my calcium ion and my calcium nitrate. This is the minimal work I would expect to see. You've got to at least overtly state that you recognize those are equal. So if I calculated Q, if I plug both these into Q, I would get 0.000625. Whoops. I messed up there, 76. Okay, and that's how I would calculate Q. So when I did my math, and you really need to double check my math on this one. This cold is really dragging me down, kiddos, but I suffer because I love my students so much. Okay, so this is Q. My K is, that's to the 7th, minus 7th. So that's Q. If I compare it to K, I find that K is larger than Q. So the drive is to stay on the product side. So the answer would be no. This does not cause precipitation. So those are two examples. I hope that is able to help you as you grapple with some of these more challenging concepts in chemistry. Thanks for joining me.